We're going to have a quick look here at the idea of linear coding. So if you look at these two sets of data, what you can see is that basically every single set in the X list of data has had 120 subtracted from it to give the Y values. Now let's imagine that we took the mean of these Y values. That would come out as being 4, and the standard deviation for those values would come out as being 2.94. Now let's have a think about what we would expect the mean to be then for this original set of data. Well, hopefully it's fairly intuitive to see that if each bit of data has got to have 120 added onto it, that the mean must also have to have 120 added onto it, so it would make it 124. Whereas the standard deviation measures the spread of the data, how spread out is the data. And you can see that actually this data here and this data here, the spread is exactly the same. The deviation from the mean is exactly the same for both sets. And so the standard deviation is not going to change at all. If we have a look at a second example, we can see with these bits of data that every one of these has been multiplied by 10 to give these ones over here. So if I work out again the mean and standard deviation, this time round the mean is going to be also 10 times bigger than it was before, so I'll multiply by 10. The standard deviation, is that going to change this time? Well, yes it is. This data here is 10 times more spread out than the data in this list here. So the standard deviation has definitely changed, and it will have changed by a factor of 10 as well. So it will have a standard deviation of 40.3. To summarize that, we can say that adding or subtracting a value to a data set is going to change the mean, but it will not change the standard deviation. So the mean will go up or down by the same number, the standard deviation won't. However, if we multiply or divide a set of data by a particular number, then we'll be multiplying both the mean and the standard deviation by that number. Both values will change.